Good morning, everyone. We are in the second part of Lesson 16, and Lesson 16 is helping us think about using inverse operations as a strategy to solve algebraic equations when we don't know some number. Yesterday's lesson sort of helped us set it up. Today's lesson is about reading and solving problems that are written in a word form. We sometimes think of these like as word problems. And sometimes when people see or hear word problems, they start getting afraid and thinking like, I don't know how to do that. It's too confusing. So we're gonna go through a couple of them and talk about them and think about some strategies. So first of all, I'm going to start on number 26. Number 20 on page 283. Number 26 says when a mixed number is decreased by 6 and 1/4, the result is 9 and 3/8. So when we think about those words, let's think about each one and what they're trying to tell us so that we know what to write down on our paper. When a mixed number, doesn't tell us what it is, just says a mixed number. If it's a mixed number that we don't know what it is, it's that mystery number. And throughout this whole unit, we've been thinking a mystery number, that's when we put a letter in. So it says let M be the mixed number. So it tells us when a mixed number, and then it tells us use M for that. So that's when you stop, when you read that, you stop and go, okay, I know that there's going to be an M. The letter that they're helping me with, they're helping me choose, is M. So I'm going to write that down. Then I'm going to go back. Notice how it's a back and forth. I read, I pause, I write something down. I go back and read, think, write something down. So let's go back. When a mixed number, got it, M, something we don't know, is decreased by 6 and 1/4. What operation sounds like it would be decreasing something? If you're not sure what decrease means, do you know what increase means? We might hear the word increase more. Increase means go up. Decrease is the opposite, means go down. So it goes down. So some mystery number, M, goes down by 6 and 1/4. If it's going down, that sounds like something is being removed from it. So that's subtraction. So a mixed number is decreased by 6 and 1/4. Now we're going to do the same thing. We pause, go back and read again, and look for the next thing. When a mixed number, got it, is decreased, got it, by 6 and 1/4, got it, the result is 9 and 3/8. What does the result mean? Means what happens, the end, the answer. So if it's the result, we know that means that's the answer. The result, I'm going to write equals. And then it tells us the result is 9 and 3/8. I'm kind of running out of room here, but that's all right. We can squeeze it in. So some mystery number is decreased by 6 and 1/4. The result is 9 and 3/8. Now, remember if we modeled this out, if you're stumped right now, go ahead and model it out. Please, please, please do it. And it's hard to model things that are like fractions or decimals, and I totally get that. But think about a mystery amount, something we don't know. Then think about taking away 6 and 1/4 from that mystery amount. And what's left is 9 and 3/8. Well, try that inverse operations. What if instead of taking that away, what if we just left that in there? So we added it back in. We just left it right in that group. We didn't take it away here. And then we put it on here. Remember, we talked about we could put the amount on both sides. Here's my secret tablet. It's deconstructed right now, but I can quickly reconstruct it for us. I say that. Oh, whoa. Well, Not sure if that's going to stay there for a second, but remember we talked about we can put more on both sides. We could take the same away on both sides, but we have to do it to both. So if instead of taking away 6 and 1/4, what if we added 6 and a fourth to each side? This would be 0 then. That just crosses out. If you take away 6/4 and add 6 and a fourth, it's just 0. So it just stays as the mystery group. And then we have 9 and 3/8 plus 6 and 1/4. So 9 and 3/8 plus 6. Now I know when I'm adding fractions, they need to have a common denominator. The good thing is fourths and eighths are really easy. I know that there's just twice as many eighths and then twice the same numerator. So I know 1/4 is equal to 2/8. So I get 15 and 3 plus 2 is 5/8. So I start now. Now, before you end, the last thing before you do is go back and say, does that make sense? 15 and 5/8 is a little more than 15 and a half. If you started with 15 and a half and took away about 6, and 6 and a fourth, 15 and a half minus 6 and a fourth, would that give you 9 and about a fourth? It would. So once you finish, go back and forth, read, write something down, go back and read, write something down. And don't forget to stop and think in between. Then, once you get your answer, say, does that make sense? In this case, it does make sense. Let's try another one. All right, let's look at number 27. It says, when a decimal is increased by 56 hundredths, the result is 8/10. Notice how I'm reading and pausing. I'm not just reading. When a decimal number is increased by 56 hundredths, the result is 8/10. It's really hard to understand what's going on if you're just blazing through reading as fast as you can. That's not a time that you can pause and really process each part of the question. And that's a good strategy. That reading and pausing is a good strategy for helping you be successful. So when a decimal number doesn't say what it is, it says when a decimal number. What are we thinking about that? Hopefully you're thinking, I bet that's a mystery number. I bet that's going to be a variable. There's going to be a letter there. When a decimal number. Now, we keep on reading then. At the end it says, what is the number? And then it says, let D be the decimal number. So it tells us we're going to be using D. So when a decimal number, and it tells us, use D. There it is. When a decimal number, a mystery number, we don't know what it is, we're using D, is increased. Now, there generally are two operations we generally think of that are going to increase things: addition or multiplication. But when it just says increased and not like increased by a certain amount of times, if we hear that word multiple times, we think addition. Increased, we think addition. So when a decimal number is increased by 56 hundredths, when a decimal number, D, is increased, add, by 56 hundredths, there's no whole number, so we're going to put a 0 on the decimal point. When we hear 56 hundredths, we know we have to write the number 56, and we know it has to end in the hundredths place. So this is the hundredths place, so 56 has to end here. So I write it to end there. The result, we heard this last time, the result, remember that means what happens at the end. It's what it equals. The result is 8/10. So there's no whole number. It's just 8/10. And we hear 8, and we know it has to end in the tenths place. That's the first space after the decimal. So D The decimal number is increased, and the result is 8/10. So there we have our problem set up. Now, how are we going to solve it? Well, we have a mystery group, then we put on 56 hundredths more, and that equals 8/10. Now, sometimes for decimal problems, it helps people if they think about it in terms of money. Some amount of money is on one side of the teeter-totter. Now, this is weird because the teeter-totter sign is right there because I wrote so much, but that's okay. Some amount of money, we added 56 cents, and that gave us 8/10. How much money is that? What money gives us tenths? What money is worth tenths? It's dimes. So how much is 8 dimes? I hope you said 80 cents. So some amount of money plus 56 more cents equals 80 cents. Again, if you're stuck, pause and model that out. Okay, so I drew my, I actually drew my teeter-totter because my teeter-totter's misbehaving a little bit today. Uh, and so the value here sometimes wouldn't always equal a weight either. So the value on the one side, remember we heard, was 80 cents on this side. And this might be a little hard to see. The colors might be a little tricky. Well, that helps you. No, I'll just make some tilt. Over here, we were increasing by 56 cents. So here's the 50 and the 6. So what did we start with? So there's quite a lot of ways you could solve this. So you're going to say to yourself, what's the best? Do I want to use inverse operations? Do I want to take 56 cents and count on to get to 80? There's a lot of choices and none of them are wrong. They're all right as long as it works well for you and you can find the answer. So in this case, for this particular problem, I would probably choose to count on because I have 56. So I know if I take 4 more pennies, now I can swap that whole amount for another dime. So I added on 4 more pennies. Then I'm going to swap that out for another dime. So far, I have some number now plus 60 cents equals 80 cents. And I added in, remember I added in those 4 additional pennies. Well, how am I going to get them to 80 cents? Well, I need 2 more dimes. So there's my 2 more dimes. So I'm going to add in additional 20 cents. So how much did I end up adding in over here on D to make 80 cents? I hope you're seeing I added in 24 cents. Now, you don't have to change this money into, or this problem into money. It's okay to leave it as decimals and solve it any way you want. The reason I say just money is sometimes if decimals are tricky, sometimes it's easier to think about it in money because we know a lot about money. We're coming very close to the end of this unit. So next week we'll finish up the unit and then we'll do the review and have our unit test. If any part of this is feeling really confusing, you can always go back and rewatch a video and try it again. And I do mean try it. Please don't just watch me try it. Actually try it and it will become more clear for you. And remember, you can always let me know, call me or chat me or email me with questions so I can help you. See you next time. Bye.